Let's talk about relational database and SQL or SQL today. A database is a set of two-dimensional tables. You can think of a data table as a spreadsheet like Excel, in which you have columns or fields and rows. We refer to some of these databases as relational databases because data or entities in these data tables have relations to one another. For example, field values in one table may reference other records in the same table or in another table, and therefore they establish some kind of relation among one another. There are many different relational database management systems, commercial ones such as SQL Server, Oracle, Microsoft Access, Sybase, and so forth. There are open source ones which are also very good, such as MySQL, MariaDB, and PostgreSQL, which are very widely used as well. Most of these database systems that we discuss are server-based. That means if you want to access data in those database systems, you do need to connect to a server and so that you can access the database. But there are also file-based database systems such as Microsoft Access, FileMaker, SQLite, where the system is really based on one or multiple files. So as long as you have access to the files, you have access to the databases. Now, regardless of which database systems you use, most of these support the standard structured query language, or SQL. Now, SQL is the one language that is used by these different systems. So even if you switch from one database to another, you can continue to use the same language. So it makes things much easier when you either make the decision to change your database for your company, or you move to a new career where you have to use a different system. You continue to speak in the same language. However, there are dialects of the same language that are used by different systems. We call these dialects because these systems use the same language but with some minor changes to the language because they want to support special features in their own systems. Now, to make sense of the relational aspect of a relational database, let's take a look at the data table here. The data here are about employees in the organization. And just for the sake of discussion, let's just look at 3 records here with the employee ID, name, hire date, grade, and manager ID. If you look at the first record is 102, 03, 04, the employee ID John Brown, and this is the information related to this particular person named John Brown. If we look at the second person, for example, the second record, Fred Smith, which of course has a different employee ID. But if you look at the manager ID for Fred Smith, which is 102, 03, 04, it's actually a reference to the first record, John Brown. And that established the relation here because John Brown is actually the manager or the boss to Fred Smith. Okay, so through this kind of field value reference, you can establish relations among the records in a table, even in multiple tables. And that's why we refer to these kind of databases as relational. Now, let's look at another example just to generalize this concept of relational databases. Imagine you are running a store, an online store, perhaps for musical instruments. In order to organize your products, perhaps you put them in different categories, such as guitars and drums. Okay, and so, for example, we have three categories here with the category names and then category IDs. Now we can also have the products table, where you have the product's basic information, product ID, product name, and the list price. But because each product should belong to a particular category so that you can better organize them, we can put a specific category ID for each product here. So as you can see, the product number 1, number 2, number 3, they all belong to category ID 1, which if you look at the first table, the category table here is the guitars. Okay, so by using the category ID in the product table, you can establish a relation between the products and the categories table. And in this case, this is a many-to-one relation. Because think about this, a product does belong to only one category. But one category can have multiple products. And so many products belong to one category. That is a one-to-many relation. Or you can say it's one-to-many relation. Okay, so there are also other kinds of relations such as one-to-one, many-to-many. We're not going to cover everything here, just to touch base on this basic concept of relations. Now, talking about the language that we mentioned earlier, the structured query language, or SQL. It is a common language, the standard language that you can use to work with databases. It has been supported by most relational database management systems, such as MySQL or SQLite. And there are actually two sets of statements in the SQL language. One is called DDL, or Data Definition Language. They include statements such as those to create or drop databases, and statements to create, change, and remove tables. So these are for data definition, or basically to define what the data structure should be for the databases. And then the other part of the language is for data manipulation. So it's DML, Data Manipulation Language. And the statements include those to select or to search and retrieve data from the database, to insert or to add a new record into the database, to update an existing record, and to delete records in the databases. So these statements are for data access and manipulation. So it's part of the DML. So let's first talk about DDL, because this creates a basic definition or structure in the database. And so the first one I would like to touch on is to create. How do we create tables? So for example, we saw the products table, right, with product information. How can we create a products table so that we can accommodate the different types of fields that we want to have, such as product ID, the category ID, product name, price, and so forth. Right? So this is an example to create table, and the name is called products. And we have a product ID, which is int or integer. And because this ID is required, we make it not null. That means you have to provide a value for the product ID. And then we also said that this product ID is a primary key. A primary key is basically a unique ID, a unique identifier for each record in the table. So the product ID should be unique for each individual product here. And then there is also the category ID, which is also an integer. But this category ID is actually a reference to the category ID in the categories table, okay, to establish the relation. Remember the one-to-many relation between the products and the categories. And then we have the product name, which is for voucher or variable character. It's essentially a string or text, okay? And the number here specifies the maximum length of that string. So 255 is the maximum number of characters allowed for this product name information. The list price, as we can imagine, should be some kind of currency, and so we set it to be decimal 10, 2, which allows 2 digits after the decimal point. Okay, so this defines the basic structure for the products table, and so this is something that will be created if you use something like MySQL to create a table here. This is something that will be shown as the database structure down here. So just to mention a few types of data field that you can use. So one, we have seen the varchar, which is variable characters. You can also use character, okay? They are similar. There are some storage difference between these two. There are numerical types such as integer, decimal, and others. You can also have date and time information, okay, using the date and date time and so forth. Now we have created the table, products table. We can start to populate the table with some data, right? So we can use the DML, the data manipulation language, to manipulate data in a table structure, okay? So the first statement I would like to cover is to insert a new record into an existing table. So we can use this insert into, and then the name of the table, followed by a pair of parentheses, okay? And in this pair of parentheses, you list the columns to which you want to add the value, okay? So I want to add a new record with column values for category ID, product code, product name, and list price. And then after that, I use this values keyword followed by the actual values that I want to provide to these columns. Okay, and again, they are enclosed by a pair of parentheses. Okay, so this tries to insert into the products table the values here as one record for the columns listed above. Okay, and the values should follow the same order as the names of the columns. Okay, so the column names and the values should align and should correspond to one another. Okay, and then at the end of the statement, you end with the semicolon, because semicolon signals the end of one SQL statement. So in some cases, you may be able to execute multiple statements at a time. So in that case, making the semicolon at the end of each statement is very important. Okay. Of course, if we can do one, insert one record, we can insert another record Okay, so we can insert another product, another music instrument into the table. And so after we have done these two, in your table, you should be able to see two records in there. Okay, so this is the insert statement. Now let's talk about another statement in the DML, or data manipulation language, the select statement, which is to select or retrieve rows and columns from a table, or even from multiple tables. But let's start from a very simple example to retrieve all rows and columns from one table. Okay, so select star from products. Now the star here indicates all columns. Okay, so that means I want to select all columns from the products table. Because I do not put any limits to or condition to this select statement, it's going to select all rows as well. So the result of this will be all the data from this particular table. Whatever data that have been populated in the table will be retrieved here. So currently it looks like there are only, at the point of this select statement, there are only 3 records. So 3 records will be selected and retrieved and shown in the result. Now, how can we only retrieve certain rows or records with a condition? We can use the where clause. Okay, so again, we can continue to use this select star from products to select all columns, but now we want to limit the rows we want to show. Okay, so we can put where, and if you are only interested, for example, in the category number 2, then we can set category ID equal to 2. And so what it does is going to filter the other categories out and only retain the product records that belong to the category ID 2. Now, you can also retrieve selected columns and rows and put them in a specific order. So for example, if you only want to show product name and list price, you can do select product name, comma, list price. If these are the only 2 columns you are interested to see from products from the table. And then of course you can put a where condition to look at the data records that you are interested in. And then in the end, you can sort them by a particular order. So in here, it's going to order by list price, ASC, which is for the ascending order. So it's going to list all the products here. And as you can see, the order is increasing, okay, from $2.99 to $4.99, okay, because we put this order by list price ascending. Let's look at more examples on this SQL retrieval and filtering. So we know we can sort the result in a particular order. So for example, by the list price, right? So we select product ID, product name, list price from products, and then we order them by the list price. We can also add a limit or a condition to the select statement so that we can only retrieve certain records from the database. And so here we have a where clause just to select the products with the list price less than $4.50. Okay, so this is the result. Now when we select columns, we can also change the names of the columns with an alias, okay, using the S. keyword. Okay, so for example, when we select from the products, we can select product ID. If we like the name of the column, that's fine, we can keep it there. We can select product name. If we think this name is really too long and we want to make it shorter, we can set product name as name. And so this column becomes the name column. And then we can also have this price as price. So now the list price becomes the price column. And so in the result, you will see that instead of showing product name, it's showing name. And then instead of list price, it's showing price. Now, the as keyword is actually optional. Okay, so instead of product name as name, you can actually type product name space name, and actually that will do the same thing. Okay, so the same result can be achieved without the as keyword. Sometimes when we try to retrieve sometimes when we try to query a large database, the result may be too many, and it will be difficult for us to take all the results and show in one page. So it does make sense sometimes to limit the number of rows to retrieve. Okay, so we can use the keyword limit followed by a number to limit the number of rows we want to retrieve and see. So even though this select statement may return with millions or even billions of records, the result will only show the first three. Okay, so this is one, and this will retrieve the first three rows. There is another parameter here in the limit. Okay, so the full limit clause should be limit 0, 3, which means we want to start from the 0. The offset is 0, which is the first record, and then we want to return the 3 rows from the starting point, which is 0. Okay, so this will retrieve the same from the previous page. Okay, the same first 3 rows from the products table. But sometimes you may want to change the offset. So for example, here I change the limit to limit 1, 3. Okay, so we are going to have offset 1, which is the second record, because 0 is the first record, 1 is the second. So we are starting from the second record and want to retrieve 3 rows starting from the second. Okay, so it's going to be the 2, 3, and 4. Those records will be retrieved. Okay, so this limit with the offset is particularly useful for you to develop an interface where you may have a page up, page down function, right? Because you may want to only show perhaps 10 items at a time. You do not want to overwhelm your user. And so this is a very common practice, just to show a limited number of records at a time. We encounter the where clause with certain conditions, right? And so we can specify conditions such as, okay, list price less than a particular amount, or something equal to another, right? So there are different conditions or comparisons you can make here using the equality or inequality comparison. Equal to, greater than, less than or equal to, or not equal to, things like that. Okay, and we can combine these conditions to form a more complex condition if you really need to do that. Okay, so let's look at one. This is a compound condition where you want to select the product name, list price, discount percent they added from the products table, where the date added should be greater than this particular day, which means it's after this particular day, or this price is less than 500 and discount percent is greater than 25. So it's more than 25% discount. So perhaps this is a particular condition you want to use to look into your data, to run some analysis, and perhaps there are certain products you want to identify for some marketing purpose. So the result can be something like this based on the conditions that you specify. Now, just now we did not use any specific like parentheses to specify in which order these conditions should be combined and evaluated first. But if you want, you can do that. And so here we do use a pair of parentheses, for example, to make sure that this or condition will be evaluated first before the end condition is used. Because these operators can come with different precedents and they may be evaluated in a different order than you expected. So having a pair of parentheses, I can make sure that they will be evaluated first before another. And so you can have an embedded structure of many pair of parentheses to make a more complicated or complex logical expression for the condition. But this is just one example to show you that if you do this, you get a very different result, even though it looks like you are having the same conditions. And you may want to think about why this is the case, why this is different. Okay. So we know we can retrieve all rows from a table. So let's imagine perhaps, okay, you continue to run your online store to sell things, and of course there are going to be orders coming in, and you need to have a system to manage your orders. And one query you may want to run is to see all the orders that have been placed on your website, right? So you can select the order ID, order date, ship date from your orders, and this is the result. So maybe 3 orders have been placed. Now, if you take a look at the result here, the ship date column has one record in here, has a value for the ship date, which indicates that this particular item has been shipped on that particular day, right? But for the other records, the second record and the third, the ship date is null, which means looks like this product has not been shipped and there is no ship date yet. So we can take advantage of this kind of null value for our select statements. So for example, we can actually select all the orders where the ship date is null. And so if we assume that if something has not been shipped, the value should be null, then here we're essentially doing, we're querying the database to see what orders have not been shipped yet so that we can process them in time, right? So with this where ship date is null, we can retrieve all the records without ship date or the orders that have not been shipped yet. Okay, so this is null value, which means there's no value yet for that particular column. And of course, if you want to retrieve the other orders, the orders that have been shipped, that means the ship date is not null, or the ship date has been provided. And so you can use where ship date is not null. And that will retrieve the first order, which you probably have shipped. We know we can use the order by for sorting. And just now we showed some examples where you can sort by a particular column. But in fact, you can actually sort the result by one or multiple columns. and you can actually sort them in the ascending or the descending orders. So let's look at an example here. So you can select product name, list price, and discount percent from the products table. And of course, if you want to specify a condition for the retrieval, you can specify that using the where clause. And then at the end, you can order by product name. And so by default, this is going to sort the product name in the ascending order. And so you will see that they are sorted alphabetically. But we actually can sort the records in the descending order. And so here is another example where you sort by the list price in the descending order with the DESC keyword. Okay, and so you will see that this price is from the highest to the lowest. You can also sort by two columns. Okay, so at the end of the statement here, you order by the discount percent, and by default this is actually ascending order, and then list price in the descending order. So first it's going to order by the discount percent first. But imagine when you have lots of products, some product may share the same discount percent. And so among those products with the same discount percent, then you are going to sort them in the descending order of the list price. Okay, so this is the order in which they will be sorted by. Okay, so look at the table here. It's first sorted by the list price, by the discount percent. Okay, and then secondly, it will be sorted by the list price. Now let's talk a bit about join. Join is a very powerful tool to get data from multiple tables. You can join the tables based on their relations, and this is what you should do. There should be a relation before you join a table. If there is no such relation, you cannot join the tables together. Okay, and so that by joining the table on their relations, you can pull data from the different tables together. Here's one example. Imagine you have a table for customers that maintains all the detailed information about the customers, customer ID, customer's name, customer's address, and so forth, right? And then you have an orders table where you keep track of what the orders that the customers have placed on your website. And of course, when the customer place an order, you do not want to kind of copy all the customer information into the orders table, right? You only need to keep track of which customer ID has placed that order. And so in the orders table, you most likely only keep track of the customer ID. Now, when you try to analyze your data and try to pull things together, you probably want to kind of connect all the information back together so that you can not only see the customers' names, but also information from the table as well. Like, okay, on which date the customer has ordered certain products and what are the names of these customers, for example. And so this information comes from different tables, and we should join them together to find out. So the example here, we select first name, last name, which are from the customers table. We also select order date, which supposedly should be from the orders table. Okay, so we can see that they are from two tables. And so indeed they are from customer, which then joins the other table, orders. And how do we join them together? And this is their relation on customers.customer ID equal to orders.customer ID. which means for two pieces of information to come together, for the names and the order date to come together, their customer IDs have to match. Okay, so a customer has to have a record in the customer table and the corresponding record or two in the orders table in order for all these data instances to come together. Okay, and so this on is key for the two tables because this specifies how they are connected. And then in the end, if you want to order by something such as if you want to sort the records by the order date, then you can do that. And so the result of this is that you will have the first name, last name, and the date of the order all together from two different tables. You can join table with aliases. This is particularly useful when the table names are long, and sometimes the on condition can involve multiple fields, and so you may be repeating the same table name and over again. So in this case, you can, when you select the columns from customer, you can actually put space C, which is to say, okay, I'm changing the name of the customers to C, and then I join orders, which now becomes O, and then so for the on clause, then you can set C, which is customers table dot customer ID equal to O or orders table, okay, dot customer ID. Okay, so this is to make kind of typing the query a little bit more efficient, if you will. Okay, so this should return the same result. Now, if you can join two tables together, you can join more together as long as there is a relation. And indeed, in many database systems, many different tables can have relations. Right? You can think of, okay, customers place an order, right? And the big order may have multiple order items, right? Because you have one big order, and in this particular order, you may have order a guitar, and then you also order a drum. Okay, so there can be multiple items in one order. Okay, and then for each order, it may be connected to a particular product, such as the drum or guitar. Okay, so you can essentially connect all these pieces of information together, from customers to orders to order items to products, and then pull all the information together. Okay, so of course this can get more complex, and sometimes it takes careful attention to make sure that it works out properly. Now let's talk about something useful for analysis and reporting: aggregate functions and group by. So in SQL, you have functions such as average, sum, and count to run aggregations or basic statistics. Of course, you also have min and max to get the minimum value and the maximum value as well. These are among many other functions that you can use. And there are also special functions is available in different dialects, in different systems, such as Oracle or MySQL and so forth. But these are some of them, and so let's take a look at these aggregate functions and how we can use them to run statistics. And so the first thing you can do, of course, is that, okay, let's find out how many records are in there. How many products do I have, right? So we can select count star, which means I want to count all the records. And after I run the count, I want to use this product count as name for this count value, okay, from products table. And so essentially this is going to count the number of records in the products table, So it looks like the result at the time of the execution of this query is 10. Okay, so it's going to return 10 to you. Now, I said that count star will count all the records, regardless whether you have null values or not in some of the columns. If you count a particular field, such as ship date, okay, you will only count that particular value when it is not null. Okay, and so just now from the result from the result of a query that we run, we know there were 3 records in the orders table, and only one was having a ship date, and the other 2, the ship date was null, right? So let's take a look at what the result is. So the total count, the total number of records there is 3. Okay, 3 orders in there. And then the ship count is 1, because only one record has a ship date. Okay, so this gives you the idea that when you count a particular field, I only count the non-null values. We can also find out using these aggregate functions kind of the lowest value and the highest value and the average values of certain columns. So for example, from the products table, perhaps you want to see what is the lowest list price, what is the highest list price, what is the average price. Okay, so you can use a mean, max, and average to run the statistics. Okay, so but all these are about the kind of a single column, right? Sometimes you can also, maybe the value that you try to find out is a combination of multiple columns. So for example, perhaps when you are, doing a promotion, you try to give people, your customers, a discount, right? So the actual revenue that you have is actually the price times the quantity minus the discount. That's your actual order value. Okay, and so if you want to run a sum of the order value, you do want to do some calculation before you sum them up. Okay, so here is a formula where you have the item price times quantity minus discount amount as the order's total from the order's items. Okay, so this sum is a sum of this particular formula, and you can run it. Okay, so it's about more than just one column here. Now, I would like to talk about using the aggregate functions with groups, or the group by clause. This is an extremely powerful tool because sometimes you want to do some cross-examination, right? You want to look at the statistics by, for example, categories. So here, in your online store, you have different categories of products. And perhaps you want to count the number of products in each category and look at the price of each product, such as the average price in each product. And so you can continue to do the same thing that we did just now by using the count star, which is to count the number of products, or count the number of records in the products table. You can do the average of the list price. But here you are not running the query against the entire data table, but instead you are interested in these statistics in the category ID groups, because we know the products belong to different categories. And by group by category ID, we break the list of products into different groups, and then we can count them we can average them, we can sum them, we can find out the minimum, maximum, and so forth. Okay, so the result of this is not going to give you just one record, the total sum or total count, but instead it's going to give you a number of records, one for each category ID. So if you look at the result here, there are 3 category IDs. So 2, 3, 1. They are sorted by the product count. Okay, because the category 1 has the most products in there, so it's going to be listed last. Okay, but here for each product, you're going to find out how many, for each category ID, you're going to find out how many products I have in there, what is the average price of products in that category. Okay. Now, things get a little bit more complicated when you try to join things together, try to group by, and then try to do some filtering as well. Okay, so this takes some careful examination. So first, let's look at an example here. So here we try to select category name and then count the number of products for each category name, and then try to run the average list price, okay, also for each category name. Now we know the list price and product count should come from the products table, but the products table does not have a category ID. So this category name, so this category name must have come from a different table, which should be the categories table. By joining the 2 tables together, the products table and the categories table, we can pull all these pieces of information together. Okay, so here comes the join. So products as P joins categories as C, and the condition should be P.category ID equal to C.category ID. Okay, so we'll join the 2 together. So in the end, we'll be able to use group by category name to run the statistics for each category name instead of category ID, because perhaps category name makes more sense to people, so it's more intuitive to look at the breakdown in terms of the names. Okay, now after running this, perhaps you said, okay, I only want to look at those categories with an average list price greater than 400. And it may be tempting to actually use the where condition, because we know where you can use where to filter results. But you have to be careful here. Whenever you use group by and your condition, your filtering is based on some aggregates after the group by, you cannot use the where condition. For example, the condition here is about the average price, which is based on the average function, which can only be done after the group by. Okay, so in this case, instead of using where, we have to use this having clause. Okay, so having average list price greater than 400. Okay, so having means you run the group by first, and then after you gather all the aggregates and statistics, I'm going to filter the result using this having clause. Okay, and this is the result. Okay, and so this is going to run the statistics, and then in the end, only those with the average price greater than 400 will be retained. Now, there of course is a different condition there that you can specify. If you do want to do filtering before the group by, you can do so with the where. Okay, but this is a totally different situation where you filter the number of records first based on the condition here, and then you do the group by and run the statistics. Okay. Subquery. Again, this is something that can be really powerful and can be really complex. But I'm just giving you one example here where you want to retrieve a product based on another query. So for example, if you use a select query to select from the products table and find out the average price. Okay, so there's one value that you can identify from the products table, the average price. And then based on this average price, you want to find out which products are above average. Okay, and so the condition is basically you are running a query based on the result from another query. Okay, and so you can see that this becomes an embedded query or subquery in the bigger select query. So we put this select average in the pair of parentheses and put it as part of the where clause, where list price is bigger than whatever that you have identified as the average price as a condition. Okay, and so what you are going to retrieve is a list of products above this particular average price. Okay, so these are some of the ways that you can use SQL or structured query language for to either manipulate data or to retrieve data and run some statistics and analysis. And SQL is a very powerful tool to use, and especially if there are already built-in functions for the aggregates. There are a lot of things that you can get done using just one statement or two. And so that makes things very, very efficient. Now, let's also take a look at some of the other aspects we touch on, but I want to say a few words about. Okay, so the insert, update, and delete statements in SQL. Okay, we know that in order to insert one row or one record, we can insert that record using the insert into statement. So insert into products, and then followed by a list of column names, and then values, followed by a list of values in the same order. Okay, so this is kind of the standard way to insert a record into the table. Now, if you know the order in which the database schema was constructed, kind of when you look at the table design and know the order of the fields, you can basically say follow the default order without explicitly telling okay what the column names are. So in the second statement here, the same insert into statement, I skip the list of column names and just give the values directly to the products table without saying in what order. And so this is by default to follow the same order of the fields in the table. And so you have to know in which order the fields are in the table design. Okay, but this saves some typing in creating the statement. Okay, so this is insert one row without the list of columns. You can also insert multiple rows in one insert into statement. So for example, if you insert into categories table followed by the columns followed by values, instead of one set of values for one record, you can have a parenthesis for one record, another parenthesis for another record, and then yet another for the record. So here you can see that in one statement, I actually inserted 3 records into the table. Update. You can use the update statement to update one column. For example, if you want to set the discount percent to 10 if this is for this particular product name. Okay, so this potentially sets one product. It may be multiple products, but only change the value of one column. Okay, you can certainly update multiple columns in one statement. Okay, you continue to use this update statement, and then you can set discount percent to 25, comma, description to a different description for the product for this particular product name. Okay, with the where condition here. So this updates multiple columns. Delete. You can delete one row by using the ID. So for example, delete from products where product ID equal to 6. So assuming product ID is a primary key, there is going to only be one product that will meet the condition here. And so essentially you are deleting one product that matches product ID 6. You can certainly delete multiple rows. Okay, delete from products where category ID equals to 3. So you're deleting all the products belonging to category ID 3. So it can be one or more products in there. Be very cautious though. If you delete from product or from any table without any where condition, you are deleting everything from the table. Even if you have millions and billions and trillions of records in the database, in the table, all your data will be gone if you do this. So this requires lots of caution. So this concludes kind of the brief discussion of relational database and SQL or SQL. Again, it's a very powerful tool. We cannot cover everything in one lecture. And so hopefully we'll continue this discussion into some more advanced topics, and we'll see you there. Bye for now.